Did you know there are rocks that walk across desert floors, leaving trails behind them? Minerals that grow like trees? Stones that breathe with the tides and contain the oldest living organisms on Earth? Today, I'll reveal the 15 most extraordinary rocks that blur the boundary between geology and biology. Formations that move, grow, reproduce, and exhibit behaviors we've reserved for the living. Some follow growth patterns identical to organic life. Others literally are alive, hybrid creatures of stone and cell. And the formation at number 1? It's been building itself, living and dying and building again, for over 3.5 billion years, the oldest evidence of life on this planet. These aren't metaphors. They're real geological phenomena that challenge everything we think we know about the divide between animate and inanimate. Stay to the end, because what these stones reveal will change how you see every rock you've ever walked past. Let's begin. Number 15. Pyrite crystals, fool's gold. Imagine a mineral so obsessed with geometry that it crystallizes into perfect cubes, as if mathematics itself is growing from the Earth. Pyrite erupts from host rock in formations that defy randomness. Each crystal, a golden cube, with edges so sharp and angles so precise they appear machine-cut. The metallic luster blazes like captured sunlight, the brassy yellow so convincing it fooled countless prospectors. Strike it against steel, and it sparks. The name comes from Greek pyre, meaning fire. What makes pyrite remarkable is how it achieves geometric perfection. Iron and sulfur atoms arrange themselves in cubic lattices, each finding its mathematically predetermined position as if following blueprints. This is self-organization following rules as strict as DNA replication. As it grows, pyrite incorporates other minerals, creating zoned crystals with layers like tree rings, recording environmental changes. Ancient alchemists believed pyrite contained imprisoned solar energy. They weren't entirely wrong. Pyrite forms where bacteria metabolize sulfur and can undergo spontaneous oxidation, releasing heat that mimics metabolic warmth. In coal mines, pyrite oxidation has triggered fires, the rock literally combusting. Pyrite demonstrates biomimicry in crystallization, minerals following growth patterns that mirror organic structures. Perfect cubes stack and interpenetrate, creating complex aggregates that resemble geometric coral. That's pyrite, proof that the inanimate world follows organizational principles so elegant they blur the line between mineral growth and biological development. Number 14. Fulgurites, lightning glass. Picture rock born in violence so extreme it transforms in microseconds. Sand struck by lightning and instantly fused into glassy tubes that preserve the lightning's exact path through Earth. Fulgurites lie buried in deserts and beaches, hollow tubes of natural glass ranging from inches to over 15 feet long. The exterior appears rough, but the interior gleams smooth as polished glass, sometimes tinged green, sometimes clear. Lightning strikes sand, reaching 50,000 degrees Fahrenheit, transforming silicon dioxide from countless grains into single glassy structures in under a second. The formation is instantaneous metamorphosis. Lightning vaporizes moisture and creates explosive pressure that fuses grains while simultaneously blasting a hollow channel. Some fulgurites branch underground, following electricity's fractal spread, creating root-like systems that mirror the lightning's pattern in the sky. As above, so below, written in glass and earth. Bedouin tribes call them fingers of Allah, divine signatures written in desert. Modern analysis shows fulgurites contain shocked minerals that exist nowhere else except impact craters and nuclear test sites, materials created only under extreme violence. What makes fulgurites seem alive is their mimicry of organic forms. They branch like roots. They're hollow like bones. They preserve moment and motion, frozen lightning, fossilized electricity. That's the fulgurite, rock born from skyfire, proving matter can transform instantaneously, creating forms that bridge destruction and creation. Number 13. Concretions, Moqui marbles. Imagine spherical stones so perfectly round they appear manufactured, yet they grew themselves, atom by atom, through a process that mirrors cellular growth. Moqui marbles litter Utah and Arizona deserts, iron oxide spheres ranging from pea-sized to softball dimensions. The surface oxidizes to deep rust red, uniformly rounded. Some are solid, others hollow, containing sand that whispers when shaken. The Hopi name translates to "dear departed ones," believed to be ancestor spirits playing games. These aren't rocks shaped by erosion. They're concretions, minerals that precipitated around nuclei in ancient seabeds. Iron-rich fluids percolated through sandstone, and around tiny nuclei, iron oxide began precipitating in spherical patterns. The growth was radial, expanding outward equally, just like cells dividing. The process took thousands of years, but followed mathematical rules. Minimize surface area, create the sphere. What few know is Moqui marbles aren't finished. Even now, chemical reactions continue at glacial pace. They're still growing, still responding to their environment like living things, just on timescales we don't perceive. Similar concretions on Mars, the blueberries photographed by the Opportunity rover, formed through identical processes, suggesting this growth type is universal. That's the Moqui marble, geology's mimicry of organic growth, stones that built themselves spherically because mathematics and chemistry conspired to create perfect forms. Number 12. Ringing rocks, sonorous stones. Picture a boulder field where stones chime like bells when struck. Each rock tuned to a specific pitch. The landscape itself transformed into a lithic instrument singing for millennia. Ringing Rocks Park in Pennsylvania sprawls across acres of diabase boulders. Strike them with a hammer and they ring, pure, clear tones like temple bells, each rock a different note creating harmonics that echo across the field. The sound isn't a dull thunk. It's musical resonance that seems impossible from solid rock. These are diabase boulders with unusual internal stress patterns. As rock cooled millions of years ago, it contracted unevenly, creating microscopic fractures that don't weaken the rock. They tune it. When struck, vibrations resonate at specific frequencies determined by size, shape, density, and internal fracture pattern. Each stone is effectively a natural bell. What makes this rare is that ringing rocks require perfect conditions: specific mineral composition, precise cooling rates, exact internal stress patterns. Most rock absorbs vibration, sound dies. But these stones channel it, amplify it, sing it back. Ancient peoples recognized something sacred in stones that sang. Chinese scholars documented Qing stones in ritual music for over 3,000 years. The rocks make specific, repeatable pitches, as if geology is performing composition. That's the ringing rock, proof that stone can vibrate with purpose, that music exists not just in the living, but in the lithic memory of cooling magma. Number 11. Fluorescent minerals, glowing stones. Imagine rocks that absorb invisible light, and release it as visible color. Minerals that glow electric green, blazing orange, crimson red when ultraviolet light strikes them. In daylight, willemite, calcite, and fluorite appear unremarkable, dull browns, cloudy whites. But under UV lamps in darkness, they transform. Willemite blazes neon green. Calcite fluoresces red or orange. Fluorite glows blue, green, or purple. The effect appears supernatural, as if rocks or batteries releasing stored light. The mechanism mimics bioluminescence. Minerals contain trace elements that act as activators. When UV photons strike these atoms, electrons jump to higher energy levels. When they fall back, they release energy as visible light. The process is instant, reversible, repeatable, responding to stimuli exactly as living bioluminescent organisms do. Miners in Franklin, New Jersey, discovered massive fluorescent deposits in the 1800s and thought they'd found something alive. The mines became famous. Over 300 fluorescent mineral species found in one location, creating underground chambers that glow like alien landscapes. Fluorescence serves no geological purpose. It's an accidental property. Yet the effect is so lifelike that researchers studying bioluminescence use fluorescent minerals as non-living analogs. That's the fluorescent mineral, stone that glows like living tissue, proof that rocks can appear to breathe light itself. Number 10. Pele's hair, volcanic glass strands. Picture rock so delicate it floats on wind. Threads of volcanic glass stretched impossibly thin, golden brown filaments that drift like hair across Hawaiian lava fields. Pele's hair forms during explosive eruptions when lava fountains into air and wind catches molten droplets mid-flight. The droplets stretch, elongate, cool into glass fibers thinner than human hair, sometimes only half a millimeter in diameter, yet stretching several feet long. They accumulate in crevices, drape over rocks like tangles of spun bronze. The strands are fragile. Touch them, and they shatter into fragments sharp enough to cut skin. This is glass that grows during violence. Formation requires precise conditions: low viscosity basalt, hot enough to remain fluid, expelled with force to create droplets, in wind strong enough to stretch them before they solidify. It's geology mimicking spider silk. Hawaiian tradition names these threads after Pele, goddess of volcanoes. The strands are kapu, sacred and dangerous. Modern volcanologists wear respirators because inhaling glass fibers causes severe respiratory damage. What makes Pele's hair seem alive is its structure. Each strand hollow or gas bubble-filled, light enough to become airborne, accumulating in drifts that shift with wind. After eruptions, fresh strands blow across the landscape, carried hundreds of miles, dispersing like seeds. That's Pele's hair, molten rock that learned to fly, stone stretched so thin it mimics organic fiber. Number 9. Trovants, the growing stones of Romania. Imagine rocks that grow visibly after rainstorms, expanding, budding off smaller stones, increasing in mass like living organisms, reproducing through lithic cell division. Trovants of Romania's Valția County appear as smooth, bulbous formations ranging from pebbles to several tons, surfaces marked with patterns like growth rings. Locals call them the living stones because they grow. After heavy rains, small trovants can increase mass by 4 to 5% in weeks. And they reproduce. Small protrusions develop, enlarge, eventually separate as new independent trovants. The mechanism is geological, but eerily biological. Trovants are cemented sand with high mineral salt concentrations. When rainwater percolates through, it dissolves salts, which reprecipitate on the stone's surface. Growth occurs from inside out, internal pressure forcing uniform expansion. As areas accumulate more minerals, they bulge outward, forming protrusions that detach. Reproduction through geological budding. Cut one open, and you find structures like tree rings, concentric layers recording growth phases. Cores often contain fossils or stone fragments that served as original nuclei around which Trovants began growing millions of years ago. What makes Trovants philosophically troubling is they meet several criteria for life. They grow, reproduce, respond to environmental stimuli, have internal organization, yet they lack metabolism, genetic material, cells. That's the Trovant, rock that grows and reproduces. Proof that the boundary between geology and biology isn't absolute. Number 8. Giant selenite crystals, Cave of Crystals, Mexico. Picture descending into an underground chamber where crystals larger than trees grow from walls and floor. Translucent pillars of selenite, reaching 40 feet long, still growing even now. The Cave of Crystals, discovered 1,000 feet below Neca Mountain in Mexico, is an inferno filled with the largest natural crystals ever found. Chamber temperature reaches 136 degrees Fahrenheit, with near 100% humidity, conditions that kill humans in minutes. But for 500,000 years, these conditions were perfect for selenite growth. Massive crystals cross the chamber like fallen pillars, some weighing over 50 tons, translucent enough that light glows through them. The chamber was flooded with mineral-rich water heated by magma, creating saturated calcium sulfate solution. Temperature remained stable. In this Goldilocks zone, selenite molecules added themselves one at a time, so slow and steady that crystals grew without defects, achieving impossible sizes. The crystals were still growing when discovered. Pumps that drained the cave stopped growth abruptly. If reflooded, they would resume, continuing exactly where they stopped, like trees adding rings. Ancient miners who broke into crystal chambers fled in terror, believing they'd discovered bones of gods. Scientists who first entered reported feeling they'd discovered a living organism rather than mineral formation. Selenite crystals are time capsules. Fluid inclusions contain ancient water and living bacteria trapped dormant inside stone. That's the Cave of Crystals, rock that grows slowly enough to achieve perfection, that entraps life within itself. Number 7. Meteorites with organic compounds. Imagine rocks that fell from space carrying chemical precursors to life. Stones containing amino acids, sugars, nucleobases, the molecular building blocks that could seed life on dead planets. The Murchison meteorite struck Australia in 1969. Laboratory analysis revealed something extraordinary. Over 90 different amino acids, including many found in terrestrial life, but also dozens unknown on Earth. It held sugars, alcohols, carboxylic acids, an entire organic chemistry set delivered from space. This isn't contamination. The compounds are indigenous, formed in the solar nebula over 4.6 billion years ago before Earth existed. The rocks contain pre-solar grains, dust particles older than our Sun. These meteorites are messengers from deep time, carrying chemistry that predates biology. What's philosophically significant? If space rocks naturally contain life's building blocks, then seeding planets with organic chemistry is inevitable. Earth's early oceans likely contained organic compounds from meteorite bombardment. Life didn't have to invent its starting materials. The rocks aren't alive, but they're pregnant with potential life. Recent analysis found the organic compounds show handedness bias, one molecular form slightly more common, characteristic of biological chemistry. That's the meteorite with organic compounds, rock carrying life's recipe in molecular language, proof that the chemistry of biology is cosmic and common. Number 6. Staurolite, fairy stones. Picture a mineral that crystallizes in perfect cross shapes. Geological accidents of symmetry so precise, they've been worn as protective amulets for millennia. Staurolite forms in metamorphic rocks, crystallizing in the monoclinic system. Except twinned crystals intersect at 60 or 90 degrees, creating shapes that appear to be deliberate crosses. The stones are iron-aluminum silicate, reddish-brown to black. Some appear as X-shapes. Others form perfect perpendicular crosses indistinguishable from religious symbols. What makes staurolite remarkable is mathematical precision. Crystal lattices interpenetrate at exact angles determined by atomic structure, but the resulting form appears designed. The crosses aren't superficial. They're three-dimensional interpenetrations of two complete crystals, achieving perfect symmetry. Cherokee legend claims staurolite crystals are spirit tears that fell when they heard of Christ's crucifixion. Pocahontas allegedly wore one. Soldiers in the Civil War and both World Wars carried them as protective talismans. Geologically, formation requires specific conditions. High-grade metamorphism at precise temperature-pressure combinations. But from countless rocks meeting those conditions, only some produce twinned crystals at exact angles creating crosses. That's the staurolite, mineral that crystallizes in sacred geometry, proof that mathematics generates forms human consciousness interprets as meaningful. Number 5. Lithops, living stones. Imagine plants that evolved to mimic rocks so perfectly that even standing over them, you can't distinguish stone from succulent until they flower, splitting open to reveal vivid blooms. Lithops are succulents native to southern African deserts, each plant consisting of two fused leaves forming a stone-like body. Surfaces replicate surrounding pebbles exactly. Same colors, textures, patterns. Camouflage is so precise that herbivores walk past repeatedly. Only during flowering do they reveal themselves, splitting to produce daisy-like flowers, impossibly large for their tiny bodies. This is evolution's answer to extreme predation. Become invisible by becoming geology. Lithops reduce themselves to absolute minimum. 2 photosynthetic leaves, a taproot, that's all. Leaf surfaces contain window cells allowing light to penetrate while maintaining opacity and texture of stone. Approximately 40 Lithops species evolved independently to mimic specific rock types. Each matches local geology so precisely that transplanting them to areas with different stones makes them suddenly visible. Gustav Schwantes described the first species in 1927, after collecting what he thought were pebbles, and later finding them flowering in his bag. Even trained botanists can stand within a meter and not see them. That's the Lithops, life that learned to impersonate death so perfectly it becomes functionally invisible. Number 4. Breathing rocks, tidal zone formations. Picture rocks in tidal zones that appear to inhale and exhale. Porous formations that draw in seawater during high tide and release it during low tide, hosting entire ecosystems that make the rock literally alive. In intertidal zones, rocks undergo transformation. What appears solid is actually porous matrix riddled with channels and cavities. As tides rise, water saturates these spaces. As tides fall, water drains. The rock breathes, inhaling seawater, exhaling it twice daily, synchronized with lunar cycles. But the breathing is more than mechanical. The pores contain entire communities: coralline algae, sponges, worms, bacterial biofilms, even small fish. These organisms filter nutrients from seawater as it passes through. The rock becomes a living filter encased in stone. The organisms actively modify the rock. Boring sponges dissolve calcium carbonate. Algae precipitate new mineral layers. Worms excrete binding mucus. The rock simultaneously erodes and grows, constantly remodeled by life it hosts. It's not container and contents. It's a hybrid entity. Recent studies discovered biofilms inside tidal rocks communicate chemically, coordinating metabolic activity. When fresh seawater enters, bacterial communities detect oxygen levels and adjust respiration collectively. The rock's internal ecosystem operates as a distributed organism. That's the breathing rock, geology animated by biology. Proof that life can colonize stone so thoroughly, the distinction becomes meaningless. Number 3. Jade nephrite, the living stone. Imagine a stone believed across cultures to contain life force itself. Rock that feels warm to touch, that changes color with body heat, that practitioners claim can heal because it's partially alive. Jade appears in two forms, jadeite and nephrite, both tough, dense stones with waxy luster. The surface feels almost warm, never cold like other stones. This isn't imagination. Jade's molecular structure has low thermal conductivity, so it absorbs body heat and retains it, creating the sensation the stone itself is warm-blooded. For over 8,000 years, jade has been considered alive in Chinese culture. Traditional belief holds jade contains qi, life energy, and wearing it allows energy exchange. The stone allegedly changes color slowly over decades, growing more vibrant as it absorbs the wearer's essence. Analysis shows this is partly true. Jade's color shifts due to oils from skin infiltrating microscopic surface fractures. Mesoamerican cultures independently developed identical beliefs. Maya and Aztec civilizations valued jade above gold, using it for burial masks to preserve life force. They noted how jade felt different, alive in hand, and concluded it must be solidified breath. Modern materials science reveals jade is tough because of interlocking crystalline fibers at microscopic scales. This structure is oddly biomimetic, resembling connective tissue more than typical minerals. That's jade, a stone that feels alive, that carries warmth of flesh, that cultures across oceans independently recognized as containing something more than mineral. Number 2. Sailing stones, Death Valley. Picture boulders weighing up to 700 pounds that move across a dry lakebed, leaving trails behind them. Tracks proving stones traveled hundreds of feet while no one watched. The racetrack Pele in Death Valley is a perfectly flat, dry lakebed. Scattered across it, rocks ranging from pebbles to massive boulders, and behind each, a track scored into clay, sometimes straight for hundreds of feet, sometimes zigzagging, sometimes looped. The tracks prove stones moved, yet for decades, no one witnessed it. Theories multiplied: magnetic anomalies, aliens, wind, but rocks were too heavy. The mystery persisted until 2014, when time-lapse photography captured truth. On winter nights, when rare rainfall floods the playa and temperatures drop, water freezes into thin ice. As sun rises, ice breaks into large floating panels. Wind catches these panels, and panels push rocks, sliding them across mud beneath melting ice. But even explained, the phenomenon feels animate. Rocks move only under specific conditions occurring perhaps once per decade. They move in groups, coordinated by ice panels, creating parallel tracks as if traveling in formation. Native Timbisha Shoshone avoided the racetrack, believing stones moved through ancestral spirits. Even knowing the mechanism, watching a boulder's track curve across emptiness, it's impossible not to feel you're witnessing intention without consciousness. That's the sailing stone, rock that moves across emptiness, leaving proof of impossible journeys. Number 1. Stromatolites, living stone. Imagine structures that are simultaneously rock and organism, layered mounds built by bacteria, constructing themselves for 3.5 billion years, making them the oldest continuously living things on Earth and the first organisms to terraform our atmosphere with oxygen. Stromatolites cluster in shallow marine waters as rocky domes, columns, or sheets layered like ancient bark. Surfaces feel rough, coated with sticky bacterial mats. Cut through one, and layers reveal themselves. Hundreds of laminations, each representing one day's bacterial activity fossilized into rock. This is geology created by biology in real time. Cyanobacteria form dense mats on surfaces. They photosynthesize, releasing oxygen and secreting compounds that trap sediment. Each day, new sediment covers bacteria. Rather than being buried, they migrate upward, establishing new layers. Repeat daily for centuries. The result is laminated rock that's simultaneously alive and lithified. What makes stromatolites world-changing is that 2.4 billion years ago, they were everywhere. As they photosynthesized, they released oxygen, a poison to most organisms then alive. The oxygen accumulated, rusting the planet, eventually saturating into atmosphere. This great oxygenation event was extinction catastrophe caused by life, but it enabled everything that followed: complex cells, animals, us. Today, stromatolites persist only in extreme environments: Shark Bay, Australia, where hypersaline water excludes grazers. They're living fossils. Structures identical to modern stromatolites appear in 3.5 billion-year-old rocks. Every stromatolite is built by bacterial descendants of original mat builders, an unbroken lineage across most of Earth's history. What stromatolites reveal is that the boundary between living and non-living can be erased entirely. They're ecosystems that become geology, organisms that transform into fossils while still alive. That's the stromatolite, the oldest builders, the first terraformers, rocks that are alive and life that becomes rock, proof that the planet's first complex structures were built by microscopic builders over the longest possible time, that patience at bacterial scales can literally change worlds. These are Earth's geological anomalies, 15 formations that move, grow, breathe, reproduce, and blur every boundary between animate and inanimate. They're measurable phenomena, proving that life and stone exist on a spectrum, that organization and growth aren't exclusive to biology. And scientists studying these formations are discovering that the chemistry of life and minerals are intimately connected, that the first organisms likely emerged from rock-water interfaces, that life didn't conquer geology, it partnered with it, creating hybrid entities, teaching us that the question, is it alive, may be wrong entirely. The right question might be, What does alive mean when stone grows and walks and breathes?